In this video, we're going to go over how to evaluate the definite integral of a function given only its graph. In part A, it says given the graph of f of x to your right, evaluate the definite integral from -3 to 3 of f of x dx. Now, one thing you should recall is that the definite integral is just the net area. And what is the net area? The net area is simply just the areas of the region that are above the x-axis minus the areas of the region that are below the x-axis. So the first step to do here is to just calculate the areas for all the regions. So here I see from -3 to -1, I have a region that is above the x-axis, and then from -1 to 3, it is below the x-axis. And so we can color code this in. So the one above the x-axis from -3 to -1 is simply just a triangle. And then from -1 to 3, we have a semicircle. And so we can now calculate the areas of each individual region. So I'm going to go ahead and calculate the area for this. We know that an area of a triangle is just 1/2 base times height. And I'm going to call this area 1. Now, what's the base and what's the height? Well, we see we go from -3 to -1. That is 2 units. And there's a height of 2. So both the base and the height are 2. I then see that the 2's cancel out here. And then this leaves you with an area of just 2. Now, what about the semicircle? I'm going to go ahead and call this area 2. And we know that the area of a circle is simply just pi r squared. But here we have half of a circle. So it's going to be pi r squared divided by 2. But what is the radius going to be? Well, if we start from 0 and go to -2, this is 2 units. So the radius is simply 2. Another way you can think about this, from -1 to 3, that is 4 units. That is the diameter. And we know that the radius is always half of that. So it'll be 2. And so we're just going to plug in r equals 2 and see what happens. This is going to give me 4 pi over 2, which is simply just 2 pi. Now we can go ahead and evaluate this definite integral. So we can say that the definite integral from -3 to 3 of f of x dx is just the net area, which is equal to the area of the triangle, and then subtracted by the area of the semicircle, which is below the x-axis. And so we said that the area of the triangle was 2, and then we're going to subtract by 2 pi. And so therefore, this would be your final answer. Moving on to part B, this says given the graph of g of x below, evaluate the definite integral from -3 to 1 of g of x dx. Now, this question isn't necessarily harder than the first one. It's just that there's more regions that you have to consider. And before you even start the question, I highly recommend you look at your bounds and note that right away. So here it's from -3 to 1. So we will stop when x equals 1. So I'm just going to do that right now to avoid any mistakes. And so I see from -3 to -2, I can form a triangle here with an area right here. And that's below the x-axis. And we can color code this in. And then from -2 to -1, we also have another triangle, but it is above the x-axis this time. And we can color code this in as well. And then from -1 to 1, I see that we have half of a semicircle. So we can color code that in as well. And there's just one region left, which is from -1 to 1 as well, and it's simply just a rectangle. So all we have to do now is just calculate each of these areas. So I'm going to start off with the negative region. I'm going to go ahead and call this area 1. And we know it's just 1/2 base times height. What's the base and the height? Well, from -3 to -2, that is 1 unit and a height of 1. And this just gives us a 1/2. And then for the region, the triangle that is above the x-axis, I'm going to go ahead and call this area 2. It's also 1/2 base times height with a base of 1 and a height of 1. And we get 1/2. Now what about the rectangle? We know for any square and rectangle, the area is just the base times the height. And we see from -1 to 1, that is 2 units, so the base is 2. And the height goes from 0 to 1, so the height is 1. And so we get an area of 3 here. Now the last piece is the half of the semicircle. We know that the area of a circle is pi r squared, and we also know that the area of a semicircle is pi r squared divided by 2. Now because we have half of a semicircle, we have to divide that by 2, and so by doing that, we're going to get pi r squared divided by 4. Now what's the radius? The radius is simply just 2, because if we start from 1 and go to 3, that is 2 units. This gives me 4 pi over 4, which is just equal to pi. Now we can go ahead and just add all of these up. So we can say that the definite integral from -3 to 1 of g of x dx is equal to our net area, which will be all the areas that are above the x-axis, which will be 1/2 plus 2 plus pi, subtracted with the areas that are below the x-axis. And so simplifying this, we're going to get 2 plus pi as your final answer.